Hey folks, what we're going to do today is introduce ourselves to the toolkit that we'll be using in Renar 213. But first, we'll take care of some housekeeping items. I would really like you to complete the Getting to Know You survey that has been sent to you. Please do that as soon as possible so I can set things up properly for the class. And let's get right into the course. So we're going to take a tour of the course homepage. And it looks like this. Let's make it a little smaller. So the first thing that opens up is the class schedule, a little bit of an introduction. Uh, I'm borrowing heavily from this person from Duke University. She has spent a great deal of effort putting together the basic structure for this course, and I've learned a lot by following her example stuff. Uh, this course is protected by a Creative Commons license. So if you care about things like that, you can go take a look at the terms there. Over on the left-hand side, we have some menus that allow us to go to different parts of the course online. The page that you open up when you come to the course homepage, it's got a schedule. So the schedule has a date, it's got a topic, and it's got some materials that you can look at. Typically, the materials with this little lab icon are documents. The ones with it looks kind of like Mickey Mouse, but it's actually intended to be a camera. Those take you to videos. Hello, welcome to Renar 230. And slideshows are set up to look like this computer monitor, so that you can get to the slideshows there. One of the advantages of the slideshows is any of the links that I have put into the documents they're directly accessible from the slideshow. There are due dates set for the labs, and as the course gets populated, the labs will actually show up more. There's not very many labs. I've set up 5. We've got one final exam, so the course setup is there. I'm asking you to do some reading on before you actually go through the videos, or maybe as you're going through the videos. This book that we've labeled as R4DS is a really excellent book. Uh, that's R for Data Science, the second edition. And it is free to read on the web. Uh, and it's excellent. The the main author, the first author, is a guy named Hadley Wickham, who largely responsible for developing the Tidyverse software that we'll be using. And I'm not quite sure how to pronounce her name, but Mina Tetankaya Rundle is the person who's put together the slideshows that I'm basing this on. There's another book. It's called Introduction to Modern Statistics. It's also freely available on the web, and it's also written by our friend Mina and another. This is really excellent book for getting an application for or getting an introduction for how to use R for statistics. Uh, our application will be mostly data science. So the R4DS topics are, I would say, essential, and the IMS topics are less essential. So if we look through this menu, we've got the schedule here. There's a basic overview of the course, some attribution to the person who put in the initial development work for this. Syllabus, some information on support for the course, uh, photograph of me from a long time ago, uh, giving you some contact information, some useful links. So we're going to be using Canvas for discussion and grading. It looks like I need to update this just a little bit. And some FAQs, or frequently asked questions, that are going to be populated a little bit later. So the questions are things like this, which I have answered in a video, like this, which I will answer in a video, and something about a local install of R in R Studio instead of using Posit Cloud. You can read through those if you want. Stuff about computing access, some information about uh, troubleshooting. This will have to change, and some cheat sheets for each of the packages that we might be using. So we'll be doing a lot of graphics with ggplot. A lot of data manipulation will be with dplyr. These are all part of the tidyverse, and information on the labs and the one exam will be presented here. So as far as doing the work in this course goes, I want you to complete all of your assignments individually. I don't want you sharing answers or code with others, but you are more than welcome to discuss problems in general and ask advice from your colleagues. The exam that you have must be completed individually, so don't collaborate with anyone when you're writing the exam. Oh, this is a crowded slide. So there is a lot of code available on the web, and so you can probably find solutions to many of these problems on the web. The policy that I'm going to enforce here is that you can use any online resources you can find, but you must explicitly cite where you obtained the code you directly use or use as an inspiration. And this bottom bit here says any recycled code that is discovered and not cited will be treated as plagiarism. AI, or generative AI, is becoming a big thing. I want you to treat generative AI, such as GitHub Copilot, which you'll probably fall into as you're using GitHub, or ChatGPT. I want you to treat that the same as any other online resources. The guiding principles I want you to use is that working with AI should not reduce your ability to think clearly. We want to use AI to facilitate rather than hinder learning. And we'll discuss some of the ethical dimensions of AI, and we want to make sure we're transparent about the use of them and make sure it aligns with the academic integrity. So GitHub Copilot in particular can give you some really good ideas for code. So you're welcome to use those as examples as on your assignments. But again, if you're going to use it as in your assignments, I want you to explicitly cite where you obtained the code. So if it was from GitHub Copilot, you could say GitHub Copilot. I don't want you to do any of your writing or any of the narrative for your reports. I do not want you to write with AI, I want you to use AI on. I do not want you using AI to write your reports for you. The University of Alberta's student academic integrity policy contains a bunch of information about cheating and academic integrity and policies and procedures that are come into use when some sort of academic dishonesty has been detected. Basically, I don't want you to cheat. And if I do find you cheating, which is plagiarism, working together on exams, using somebody else's code without attribution, sharing code among your colleagues, I'll consider that a violation of the academic integrity policy, and I'll be required to report that to the dean of my faculty, which is agricultural life and environmental sciences. And if you're not sure, make sure you ask me. Okay, I want you all to succeed in this course. I think it can be very useful for your rest of your career in university and quite possibly in your professional life. I'd like you to complete all of the readings before you sink deeply into the lab exercises. I want you to ask questions of me. I'm re-emphasizing, do the readings, make sure you do the labs, and try not to procrastinate. It's really easy in one of these asynchronous classes to fall behind. And that's one of the reasons why we're doing the application exercises, which I'll talk about a little bit more um, quite frequently. Okay, let's examine the course toolkit a bit. So some details as far as operating the course goes. Most of the material will come from this website, linked at the bottom of this page, and GitHub Classroom. So your assignments will be distributed to you through an email, which gives you a link from GitHub Classroom. When you click on that link, it'll set up a GitHub repository for you to use for your assignments. And that will become more clear later. We're going to use the University of Alberta's uh, learning system, Canvas, for assignment submission, uh, discussion of assignments and exercises and course stuff, and also for you to submit PDF copies of the lab exercises and for me to assign grades to it. As far as doing the data science goes, we'll be using R, which is a computing programming language, RStudio, which is a integrated development environment that works very well with R, something called Tidyverse, which has a whole bunch of data manipulation, data tidying, and graphics capabilities built into it. What I think is a very nice writing system called Quarto, which we'll be using to do some of the literate programming things that we require from this course. Just as an aside, all of this website and all of the labs and all of the writing that I've done here has been done in Quarto. Well, me and Mina have done it. It was done in Quarto, so I hope you find that useful. And we'll be using version control through a really wonderful package called Git. We'll see the interface to Git mostly through RStudio, and we'll be using an online resource called GitHub to actually store and distribute the material. Okay, let's talk a little bit more about the toolkit. Some of this will be repetition. By the end of the course, I want you to be able to gain insight from data. So I want you to be able to take some data and try to develop an understanding of what the data actually means, what it represents. You can do a lot of interesting things with once you understand what's going on with your data. I want you to be able to do this reproducibly. So I'd like you to be able to easily uh, redo your analysis and be able to show someone how it was done. We're going to do this using modern programming tools and techniques. So R and Tidyverse and RStudio and Git and Quarto are all quite modern. And I want you to be able to do all of that with literate programming and version control. And there will be more detail on what those things mean. So, what does it mean for a data analysis to be reproducible? In the short term, we want to be able to reproduce figures from the code and tables and figures from code and data. We want to have some evidence that the code actually does what we think it does. And we want to make sure it's clear why the analysis is done, as well as what was done. Longer term goals. Once you build up a library of code, you may be able to use it on other data, or you may be able to use it to do some other things with some extensions. So the toolkit for reproducibility that we're going to be using, scriptability is something that will allow you to have all of the steps required for analysis in a script. In the perfect world, you should be able to press go on your IDE and the entire analysis from data retrieval of raw data through to the analysis and graphing, data analysis and graphing that is done through the system to be replicated with one button push. The language we're going to do that is R. Another bit that's important is literate program. So what we're programming, so what we're going to do here is use Quarto to make sure that we've got our code, our narrative or the description, the story that we're telling about the data and the output all in one place. Quarto makes it quite easy to do that. And we'll be using Git and GitHub to do some version control, which will allow us to keep track of changes that we've made to our software. And we're not going to get into it too much in this course, but Git and GitHub also allow users to share and collaborate on code quite effectively. So let's talk a little bit about R and RStudio. Well, R is an open source statistical programming language. It was developed from another language that was called S, which was not open source. Uh, It's free to use, it's free to download, it's free to modify if you want to. It's also a good environment for statistical computing and graphics. A lot of academics in particular are now using R for their statistical analysis, partly because it's cheap and understandable, and as well as because it's easily extensible with packages. Well, there's packages for almost any kind of analysis you can imagine. There are packages for GIS, there are packages for forest inventory, there are packages for wildlife habitat analysis, etc. Our studio is something that's called an integrated development environment or an IDE. Basically, it's an interface for R that makes it much more convenient to work with. So what you can think about is this statement here. I write R code in the RStudio IDE. You do more than just write code in the IDE. You run code, you can look at outputs and so on. But basically, it's the dashboard to R that we're going to be using mostly through this course. You don't need to use RStudio to program with R. You can do it. You can program with R using a very simple text editor. There are packages in a fancy editor called Emacs that allow you to code in RStudio with a text-based IDE. But RStudio is very commonly used by programmers and data scientists. It's very convenient. One of the reasons why it's convenient is that it's developed by the same people who developed the tidyverse and ggplot and other packages that make life in R much easier. This is a cheesy graphic. Uh, this picture might help. R is the engine that does all of the work for us, and RStudio is the dashboard that allows us to control what the engine is actually doing. The interface to RStudio is much nicer than the standard interface to R. Okay, one of the things that makes R convenient and easy to use is packages. And packages are nice because they include a number of functions that you can use again and again and again. They also include documentation that describes how to use them, and they also include sample data. Uh, in these packages, some of them change fairly frequently, but it is straightforward to make sure that your code is using the same packages that it initially was, or if or that it's going to use updated packages if that's what you want to do. There are a lot of packages available. Over 20,000 are available on CRAN, and some people might say CRAN, but it's the Comprehensive Archive Network. And when you get to the slideshow version of this, you can click on these links and get some better idea about what these are. Here's Hadley Wickham again, writing about our packages. And that's ugly. We're going to work with a small subset of these packages, but they will make our life much easier. So let's take a quick tour of R and RStudio. I'm going to do this locally on my Mac instead of on Closet Cloud, just because it's faster. And when you start up RStudio, you can see something that looks like this. So what we have here is a number of different windows. We've got something called this console, which I've given you a brief introduction to before. We've got a set of tabs that allow us to look at the environment, history, connections. We can load a tutorial. We can control packages with Git. For now, we'll leave it on the environment thing, environment tab. Uh, this big window has a tab to see the files that are in the directory we're currently working in, a tab that can show us some plots, a tab that will show us packages that are available and installed. The only ones installed from this page anyways are the base package. There's probably some further down that I've got installed here. You can access help. You can do some other things that we can look at later. But let's explore the use of the the console to do some basic R commands. So I am going to use this broom to sweep away the header stuff. We don't need it. It was basically just telling us version numbers. You can use R as a very simple calculator. So if you type in 2 plus 2, it'll return the answer 4. If you want to assign a value to a variable, or more generally, an object called X, you can do it with this symbol. That looks like a less than sign and a hyphen. It looks like an arrow pointing from 2 to the X. If you want to see what X is, you can do it like that. If you wanted to see what X plus 3 is, you can type it in like that, and we get the correct answer, 5. One of the important things we can do is load up some libraries, and libraries are created through packages that we've loaded. And I'm going to load up a library called Palmer Penguins, and you can see that this is being very helpful to us. Our studio is. It's giving us some completion help. We'll go to Palmer Penguins and load it. So it's already in a package that has been loaded into our. We can take a look at these data, or we can take a look at some of the data within that library. And we'll take a look at the penguins uh, object. So we can see that we've got a file with 344 lines that gives us the species of the penguin, what island it is found on, what year they were found and are measured, and different measurements associated with each of the penguins and the sex attribute associated with them. So I will hide that. Another thing that we can do is we can view a particular column in that data set. So we can refer to a particular column in penguins by writing penguins, then the $sign, then body mass. Tab shows us the body mass of each of the 338, 39, or each of the penguins that were measured. It's kind of useful. We can do some statistics on these data. So we can try to look at the mean of penguins' dollar body mass. This is going to give us a little bit of a problem. It's telling us that the mean of this is not available. We can ask directly for help on an object or a function by typing a question mark, then the name. It gives us some idea on how to use it. This documentation is usually useful, most useful for people who kind of understand what's going on. If you're a complete newbie, it would be better probably to do a Google search for something like, how do I calculate the mean for a data set, or for a vector? An R object is the right term. What we're going to do is to remove the data that are not available, coded as NA in the data set, which means it either wasn't weighed in this case, or the data got lost somehow. So if we instead do mean, use the up arrow key to retrieve some of that thing, na.rm equals true. What this will do is From this data set, remove all of the observations that have Na or not available for body mass from the object body mass in grams before it calculates the mean. So we see that there's a mean of 4,201 grams for all of the penguins that had a body mass measured. So that was a really quick tour of the basics of R and R Studio. Uh, what we're seeing here is something called the data viewer, which allows us to see the characteristics of the object that we're looking at with the view command from down here. We see that we can do some really simple arithmetic. We can see that we can assign values to objects. Uh, we can load up packages to do things. In this case, we're viewing the penguins object within the Palmer penguins data set. We're able to extract a particular variable in that data set or that object. In this case, we were looking at the body mass in grams. We can do some statistical analysis. Sometimes we get messages that don't help us very much, or sometimes we get messages that says that our answer is not available. We can get help on the particular function that we're using. And then in this instance, what we were able to do was to find that we could put this value of na.rm is equal to true into this function. It would remove the data sets that it would remove the rows that had na coded as it would remove the rows that had the body mass in grams recorded as na. So it's this window in RStudio is this RStudio interface, this RStudio dashboard is quite useful. Okay, what as we were going through that, we saw some R things that we were using, and these are the essential things that you'll need to know for the next little while. So we're going to use functions. One of the functions that we used was mean. So the way you might interpret this is if this was mean, instead of do this, it would be interpreted as take the mean of the object that is in this parentheses here. We can add other functions to other parameters to the function. And one of the things that we did with the mean is that we said take away the values that had missing values in body mass in grams. So you can think of them as verbs followed by what the verbs are being applied to. And you can grab columns from data frames. So the data frames are the tables like we saw for the penguins data. You can retrieve individual columns or variables with using this $sign. So this is saying from the data frame called data frame, show me or retrieve, access the variable called var underscore name. You can obtain documentation for objects or functions with the question mark. One of the main things that we're going to be using in order to manipulate our data and create graphics is something called the tidyverse. And it's called an opinionated collection of R packages designed for data science. And it's called opinionated because Hadley Wickham and his co-authors have very strong opinions on how data should be organized, how programs should be, how functions should be written, how packages should be written. And because of this strong opinion, all of the packages within the tidyverse share an underlying philosophy and a common grammar. So uh, if you understand what's going on in one of these tidyverse packages, you'll be well on your way to understanding what's going on in another. Hey, let's talk a little bit about Quarto. Quarto is a piece of software that will allow a user to develop fully reproducible reports. Each time you render the analysis, it is run from the beginning. So, uh, the idea of scripting. The way Quarto is organized is you put computer code in something called chunks, and the narrative or the story goes outside of the chunks, and we'll see an example of that. One of the things Quarto does is provides a visual editor for people who like what you see is what you get kind of editing experiences. My guess is that most of you will want to use that as you start. And we're going to just work through the first real applications exercise that we've set up for the course. So it's this Meet the Penguins data set that you've been assigned in class. This is the Meet the Penguins Quarto document showing up here. I'm going to get rid of hide the console for now. And what I'm going to do is to change this to a visual editor so we can get an idea of what's going on. I mentioned that our code is stored in chunks. So each of these gray things are chunks. Uh, the narrative or the story is told outside of the chunks. And what we can do is run these chunks in order just to see if they're working. So this is the first chunk. Usually you need to run the first chunk first. It gives us some information. Then we can see what happens with the second chunk. Nothing will happen because everything inside it is commented out. This code, all that will do is show us the number of rows in the Penguin data set, and we'll show you how to uh, put results from code directly into the Penguin data set. Sorry, directly into your narrative. So this blank is going to be replaced by a number when we finish going through this. So I mentioned the word render. So let's render this document. What this is going to do by default is render it to an HTML document, which is readable by a standard web browser. And let's do that. It's quite fast. It goes to a web browser and it gives us information that we want, showing us the text that we've entered. It's showing us each of the commands and the results of each of the commands. So each of the chunks of commands, and gives us quite quite understandable output. So let's go through the exercise a little bit more. Oh, what this output, this kind of output doesn't have to show up in your document if you don't want it to. Uh, but what this is doing is showing us each of the individual packages that are loaded when we load the uh, meta library tidyverse or the meta package tidyverse. So let's work with this a little bit more. I'm going to change this a little bit and give it an author. This chunk here is called YAML, yeah, or YAML. This can be used to control the way the document looks. We'll get more into that later. I'm going to hide the console again. We will leave that there. What happens when we glimpse penguins. And again, it gives us some helpful completion. As I'm developing my code, I may just want to run the chunk. What the glimpse does is kind of helpful. It tells us how many rows, how many columns uh, for each of the variables. It gives us the first few values of the variable. So I believe it's the first 10 rows. So it can give you a pretty good idea of what a data frame actually looks like. The thing that you can do is actually put the results of our calculations in directly into your text or inline in your text. You do that with a backtick. Um, on my keyboard, it's up near the upper left-hand corner of the keyboard, just under the escape key. And then you could tell it to use some R code. And the R code that we want to use is N row penguins. And that with another back tick. So that highlights this with the gray color scheme that's used for code. So we don't need to run that. What we'll do is render this and see what that does to the document. Again, we see the output of the glimpse command, and down here we see that it has uh, replaced that R function or that R command with the result of that R command, which is the number of rows in the data frame. So that was a very quick tour of R Studio, and Quarto. If you follow what I did here, you'll have your answers to the first application exercise. One thing that is useful to remember is the different environments that are in RStudio. Uh, the environment of the Quarto document is separate from the console. So you may have values that are recorded in the console, but not in your Quarto document, or values that are stored in the console and not in your Quarto document. And that'd be quite confusing for your first few times if you're expecting to see values showing up in the console. So this is just a demonstration of that. So what happens? Well, we don't get any value for X when we run it in the Quarto document because we haven't defined X in the Quarto document, even though we have defined it in the console. So we're going to use Quarto for every application, exercise, lab, project as a Quarto document. Always give you a template Quarto document to start with, and that will come from the email I send you with a link to a GitHub Classroom repository. And as we go on in the course, I'm going to give you less code to start with, or less scaffolding, and you'll be doing more and more of the work on your own as we go on. We just kind of did the recap. I've created another video, which is a detailed walkthrough of how to retrieve and submit assignments using GitHub, Posit Cloud, and RStudio. You can see that video by clicking this link in the slides, or by going to the website and clicking on the video associated with GitHub and Posit Cloud. So um, that's it for this first real lecture. You may have noticed that we've seen a whole bunch of hexagons or hexes in documentation and things that we've been going on. There's been a tradition developed that each package for our has its own logo that's contained within a hexagon. So this is a small sampling of the packages that are available. And I will see you later. Thank you for your time.